Okay, today we're talking about segment addition postulate. Basically, that's using any sort of diagram with a line segment, and it talks about 2 points on that segment. And basically, if a third point, let's say B, is to lie on that line, third point B is to lie on that line, then what must be true as far as adding those segments, AB plus BC should equal AC. And that's just the whole idea that if point B lies anywhere on this line, even if I had, let's say, point D here, if D is to be on that line, then it 100% should be true that AD plus DC is equal to AC. And basically that's giving you the idea that if I have the measurement of one segment, let's say AD is 3, and I have the measurement of another segment, let's say DC to be 5, then I should be able to come up with the measurement of this whole segment AC to be 8. And you can apply that to a couple different types of examples. One in which they give you, let's work with ABC while we're doing this. They give you the measurement of AB and they give you the measurement of BC. And you understand that AB plus BC is equal to AC. So if you're trying to solve for that, you simply substitute AB for 3, BC for 14, and then AC we know to be 17. And you could do the same thing, but in this case, you may see that, put the point a little bit down here, that they don't give you one of the small pieces of the segment. They don't give you one of the segments that make up the whole segment, but you understand, and maybe they tell you that AC is, let's say in this case, 21. So they're telling you, and you'll see me do this a lot too, is kind of in order to make or show the measurement of this whole segment, I'll show a bracket measurement where this line is associated with A, this line's associated with C, and the whole thing is 21. And that allows me to do X plus 5 is equal to 21, and that allows me to solve for this missing small piece, in this case, which is 17. Now this is a simple segment addition postulate problem, although you might be presented with one that has a little bit more to it. Maybe they don't give you measurements, maybe they're giving you expressions such as 3u plus 6 and 2u plus 4. Let's give our points again, A, B, C. So maybe they're telling you, maybe they don't even give you the drawing. Maybe they give you that AB is 3u plus 6. Maybe they tell you that BC is 2u plus 4. And maybe they tell you that AC is equal to 40. Now, using a segment addition postulate, you know that AB plus BC is equal to AC. So this is really where it comes into play, because I can substitute this 3u plus 6 for my AB, and I can substitute this BC 2u plus 4 for my BC. And then I know that AC equals 40. So I could combine like terms and call this 5u plus 10 equal to 40. Subtract 10. We'll come up here. 5u is equal to 30, which means this is multiplying, so I divide. U is equal to 6. And then if I wanted to plug in for that, or if they asked me what AB was, I could just say 3 times 6 plus 6 is 24. And 2 times 6 plus 4 is 16. And it does make sense because 24 plus 16 is 40. So everything kind of lines up here. That should be helpful with segment addition postulate.